Hello, welcome back to this series where I implement small programs related to systems programming in C++ to get to learn more about low level systems and C++ in general. Today, I'll be extending on the previous problem that I was working on, which was a multi threaded task scheduler, and will add some priority concepts to the whole scheduler instance. um, Essentially tasks the tasks that are scheduled can specify a priority, and the jobs with more priority will execute first. So let's jump into the implementation. Let me update my structure a bit, and this goes away and this comes back. Okay, so I have restructured the code from last session a bit so that I can use the same directory to store all future projects. And each of these projects could be a separate file, and then the main file is like the test file. So I've moved the task scheduler code to a header file and a C++ file. Um, so the header essentially implements the API, and the C++ file actually implements the classes. Yeah, so like the methods are implemented here, but the header is live in the header file. I have created a few new files. Like I got some idea for the future projects. Maybe I will try my hand at a rate limiter and try to implement different policies in a simple rate limiter for the next video. But okay, for this one, I want to keep it short and I want to run through this concept. So currently, when our scheduler runs in this main file, the jobs are executed, or at least jobs are picked up for execution in the order in which they are scheduled. And this is guaranteed because when we call the schedule method, it actually pushes it to a queue, and queue has a guaranteed behavior where whatever comes in first will be executed first, whatever comes in last will be executed last. So that's just regular queue behavior. And I mean, this works for regular task schedulers very well, but let's say we have a use case where we need some sort of a priority, and um, jobs can be scheduled at different point in time. So the chronological order of scheduling is not directly related to the priority of the jobs. And in this case, we would want something like a priority based scheduler. And I think one of the common examples that comes up is like a operating system scheduler. And I think there are like very nice articles online that tell like how scheduling works, and I believe it's like one of the most interesting problems in our operating system. And there are like different algorithms um, that can be implemented to have a proper scheduler. In terms of an OS scheduler, a lot of things come into picture because um, the execution of tasks or processes does not really only matter around the priority. It's also about how much resources a particular process is using, or if certain process is CPU or IO heavy. So the scheduler has to take care of all of these things, and it's really a like very critical part of the entire operating system. But essentially, yeah, like if you think about it simply, OS scheduler has to implement some sort of priority because incoming tasks that require CPU time uh, would have like some sort of a priority because some tasks are obviously more critical than others when running an operating system. So, simply put, let's say um, what we want to do in our public API is that when we schedule a job, the user should be able to also specify a priority. Hmm. And if there is no priority specified, it will take the least priority. So anything that has priority will, yeah, will kind of, we'll try to accommodate them into our scheduler, but something that does not define of a priority will be given the least priority. Let's update our API here first. So let's consider priority is an integer, like a number that is passed to us, and um, I think usually it's a confusion because okay, my screen froze. Let me just quickly. Yeah. So priority, like, it could be a misnomer because it might lead to a confusion. Um, Usually, a lower priority number would mean that it has to be put before something that has a higher priority. So, I mean, for now, I would just write here uh, greater means more, greater means has more priority. So the larger the priority number, the task is more important and would be scheduled before uh, other tasks. Um, let's come here and implement this. So int priority. Now, the way we would use this, so we'd have to rethink a bit how our tasks are stored in a scheduler because currently it's a queue, and the simplest way to include priority in this whole setup would be to introduce a data structure called priority queue. And priority queue is essentially also called a heap, and like what this data structure maintains. It maintains a certain invariant that yeah, let's look at heap. Yeah, so heaps usually have this property where it's either a min heap or a max heap. So the a parent node would always be greater than its child nodes, and this goes throughout the depth of the tree. So in a max heap, the topmost, like the root node, would be the greatest node, and as you go down the tree, the invariant would be held that every parent or every child is smaller than its parent node. And this is great for our purpose because what we could do, and one more property that heap kind of allows is you can insert new nodes to this tree, to this structure, and the heap will maintain this structure throughout. So it has a like a heapify method that kind of restructures the whole data structure such that um, the the largest or the least, depending on which heap it is, remains at the root of the node, and then so on. So yeah, like if we replace our queue, which stores the task currently, with a heap, it would just solve our problem because then we could just store all the nodes according to their priority in the heap. We could then, while removing the nodes, we could remove the topmost node and it would always be the one with highest priority. So let's check if C++ has heap data structure, and I think it does. So it has a make heap function, and what it does is constructs a heap in the range first to last. Constructed heap is with respect to, okay. Okay, so it does create a max heap. Okay. So we would just have to call make heap v begin to v end, and to add new. Okay, but the problem is that this works when you already have some values, so we would have to see if this has a method that allows us to add. What does it return? Hmm. Okay, so it does allow uh, pushing. Okay, great. So let's update the task scheduler. So instead of a vector, what's the type of heap? Does heap have a type? I think something is wrong with my display capture. Okay. Yeah, I mean, so what does make heap return actually? So it. Okay, so it works in place. Mm-hmm. Okay, so essentially, I would have to call push heap adds an element to a max heap. Perhaps I continue to provide a priority queue. Okay, this is a bit confusing. Let's check. Container adapter that provides constant time lookup for the largest. Okay, so C++ has a priority queue directly. Interesting. Okay, so priority queue, I would push the queue, and then next priority queue. Let's try this. So I would still keep the queue intact, and I would my idea would be that we create a priority queue of job pointers, and then we save the priority inside the job instance, and then we define a custom comparator where when the priority queue compares two nodes, it will compare the priority property on the job. And I want to now check how I can define a custom comparator. So class container compare. Okay. So I think I can do this std vector. Okay, so the container is like the way it would store it. Um, and the comparator would be okay. So something like comparator, and then I would do okay. I need to check C++ syntax here because it says container.value priority queue. Okay, I need to define a custom comparator. Um, okay, then I would rather do that instead of doing the lambdas thing. I would do something like this and class priority comparator, and it would have a public method saying boolean operator. Okay, I mean it's a pair here, but I want uh, the it would be a job pointer. So A and a job pointer B, and then I would have to return a boolean saying, yeah, I would first define a priority on it. Int priority, and I would say int get priority, and this returns the priority. So essentially, I would do something like return. Okay, I want to say a dot get priority is greater than b get priority, something like this. Yeah. And so now we have the priority queue defined. It has a custom comparator. It gets a job and then it compares it. Now I would have to implement oh yeah, like the previous test will start failing. Let's say is there method overloading in C++? I'm not sure. C++ method overloading, function overloading. Okay, but this case we have to understand. Wow, so many ads. I'm not sure if I want to do like overloading. Let's see. Something like void schedule. Does C++ allow this? And then I do something like okay, yeah. So I can take in a schedule without a priority, and then if there's no priority, it's just set as a priority 0. Okay, back to the priority queue. So now we have the priority queue here. I think the only change, I don't think we need a change in the API. I know, I mean, right now I'm pushing to the queue, but here instead of the queue, I would have to change it to priority queue. So priority queue dot push. And okay, I need to check what are the methods here. So push inserts and sorts the underlying connector. Okay, pop removes the top element. Yeah, we need pop top, and to access the top most element we need top. So where is the queue? Queue here is here. Yeah. So queue dot size. Do we have a size? Yeah. Size is greater than 0. That's good. Then we need. I think my recording was stuck, but so essentially, I'm just replacing all the instances to queue with priority queue, and I would do something like priority queue dot top, then do priority queue dot pop. It will remove it. Queue empty. Priority queue dot size. Priority queue dot size. Okay, and finally here we push to priority queue. So I think that should be it. Let's see if the program still compiles, and without the priority it should just work as usual. Okay, and define symbols architecture. Okay, I think I need to import priority queue somewhere. I should include priority queue. Oh no, heap. Okay, undefined symbols for architecture ARM64. Get priority referenced from priority comparator. Symbol not found for architecture. Okay. Mm, okay. So there we get a compiler error here. Undefined symbols for architecture. Get priority. Reference from priority comparator. Operator. Okay, this is coming from linker. You need to compile. No, but I think I do that. Them lumped in together. Let me think. Let me see if this works. So task scheduler me.cbp. Okay, we still get same error. Error linker command failed with exit code 1. Use V2C invocation. Okay. I think we did not implement get priority. Is that the reason? Yeah. Yeah. That was it. Did not implement the priority, and that is why it was failing. Okay, let's see. So now it should just work as before because we did not add any priority. But now let's make the examples a bit simpler so that we can see what is actually happening. Let's do like 4 threads, and let's do 4 jobs. But now, how can we simulate so a certain job has a higher priority? Hmm. Okay, yeah. Actually, what we could do is let's do only 2 threads, and let's do yeah. So before, if let's run this without priority, what would happen is job one would execute immediately because okay, no, job one will not execute immediately. But let's see. How do we simulate? How do we test priority in this case? Okay, let's keep the 2 threads busy with and until then, let's schedule 2 jobs, one with priority 3, priority 2. To make it easier, let's try to print something from our job. So let's try to actually print. What can we print? Can we print the job name? Yeah, let's try to add a name to our jobs. So like this, it also takes a name. Let's try to add one more constructor here. Where in the first argument is a name. The second one is a string, and okay. And when we execute it, we would actually print the name as well. So something like so where is execute? Okay. And then we would do something like std out. Okay, let me quickly. I think I'm running out of memory, and that is why my screen keeps on freezing. But okay, let's see. Let me. Okay. I hope it improves now. Okay, let's try to print it. Thread executing thread, and then we take in the name of the thread, std end line. Okay. So let's try to update the the actual functions that run, and let's try to just remove the prints for now. We simply want to see which thread is executing when. So yeah, so we won't see any hellos as such. Now let's try to enforce that we send name to each of these. 1, 2, okay, const char. How do I do? Okay. I'm sorry. It should not be when scheduling the job, but while creating the job. So let's create multiple jobs now, and okay. And the fourth we will give it a high priority, and then we will try to schedule job 1, job 2, job 3, job 4. Let's just give it 2, and this let's be 0. Let's try to see what happens. Yeah. So what happened here was, so this got scheduled, this got scheduled, this got scheduled, and then this got scheduled. But I think um, job 2 was already picked up before job 4 arrived. So let's try to do this. Let's try to introduce sleep here and see what happens. or probably let me make this job 2 as well. So when the two threads that we have are busy executing two sleeping jobs, and we have two like we have two new jobs, ideally, like with our previous uh, with our previous implementation, this job 3 should have executed job 3 should have executed before job 4, but I would assume in this case job 4 would execute first. Yeah, that's what I expected. That's it from the task scheduler topic, and I think I'm going to conclude this topic here and pick up a new one for the next one. Overall, in the 3 videos we covered, I tried to build a simple task scheduler first, then move to a multi-thread one, and then to a priority scheduler. And yeah, I think it was a really nice learning on the way. The next one, I think as I mentioned at the beginning, I'll do a rate limiter. So see you then.